Hello grade 11s and welcome to this video in which we are going to revise what you learned about electrostatics in grade 10. We start off with the principle of conservation of charge, which says that the net charge of an isolated system remains constant in any physical or during any physical process. This simply means that we can't create charge or destroy charge. If anything is positively charged or negatively charged, it's because it gained or lost electrons. So if we look at figure number 2, we see that the ruler is negatively charged. We can tell this by the fact that there are more negatives drawn on the ruler than positives. The cloth on the right hand side is positively charged because there are more positive charges than negative charges on this cloth. Now, in order for these objects to obtain their charges, we didn't simply create extra electrons or create extra protons. Instead, we know that in the beginning, there was an exchange of electrons. So we start off with the ruler that has a neutral charge or no charge at all, and the cloth also has no charge. We can then rub the ruler with the cloth, and when we do so, there's going to be a transfer of electrons. The cloth, which becomes positively charged, loses electrons to the ruler, and the ruler gains electrons. This means that the reason why the ruler is negatively charged is because there was a gain of electrons, and the reason why the cloth is positively charged is because there was a loss of electrons. So electrons were not just created or destroyed, they were transferred from one object to another. And this is basically what the principle of conservation of charge is saying. If you add up all of the positive charges in figure 1 and all of the negative charges in figure 1, you're going to see that they are equal to the number of positive charges in figure 2 and the total number of negative charges in figure 2. So very often in grade 10 we said that you should apply this principle of conservation of charge to two metal spheres on insulating stands. We place the spheres that are charged on insulating stands because we do not want the charge to discharge into the ground. So we may, for example, say that Q1 has a net negative charge while Q2 has a positive charge. That is, of course, because there was a gain or loss of electrons. We then may say that the two charged spheres come into contact, so they touch, and then they are separated. And we will then ask you, what is the final charge on Q1 and Q2? What you should know is that when two identical conducting objects having charges Q1 and Q2 touch, in the end, after they touch and are separated, they will have the same final charge. Now, this is very important, the fact that they need to be identical. This means that they're made up of the same material and have the same size. And this is normally what you will find in grade 10 and grade 11. What we're saying is, in the beginning, the charge that we have on Q1 is its initial charge. The charge that we have on Q2 is its initial charge. When they touch, since we are saying that Q2 is positively charged while Q1 is negatively charged, there's going to be a transfer of electrons. Electrons will always move from the more negatively charged object to the more positively charged object. And this is based on the fact that electrons repel each other and they want to be as far away from each other as possible. So they therefore move from the more negative to the more positive object. In this case, electrons are going to be transferred from Q1 to Q2. When this happens, we end up, or as a result of this happening, after these two spheres are separated, they're going to have a new charge. We can refer to this as the final charge, or Q nu. To calculate this final charge, we can simply use the formula that the new charge, or final charge if you'd like, is equal to Q1's initial charge plus Q2's initial charge divided by 2. And this is going to give you the answer that you get over there and over there after the two spheres have been separated. You need to know this formula off by heart, and you need to know how to use it. The next principle that we taught you in grade 10 is the principle of quantization of charge, or the principle of charge quantization, which says all charges in the universe consist of an integer multiple of the charge on one electron. And the charge on one electron is given as 1,6 times 10 to the negative 19 coulomb. This is just the magnitude of the charge on an electron, because we know the charge on an electron is actually negative. Now, as a starting point, I'd like to remind you that QE, this symbol, represents the elementary charge, which is the magnitude of the charge on one proton or one electron. Protons and electrons have equal charges. Their charges are always given in magnitude as 1,6 times 10 to the negative 19 coulomb. It's just that on a proton the charge is positive and on an electron the charge is negative. What the principle of quantization of charge says is that if an object has a charge, then that charge is some number that is an integer multiplied by elementary charge, the charge on one electron or one proton. We can use this formula to calculate the charge on an object if we know the number of electrons or protons on it in excess, or we can manipulate the formula and say the number of electrons or protons in excess is equal to the charge divided by the elementary charge, where the elementary charge is just given as 1,6 times 10 to the negative 19 coulomb. This number can be found in your table of constants on your formula sheet. It's normally given as E instead of QE, and sometimes this formula takes on the form Q divided by E. But you know that the charge on an electron is equal to the charge on a proton. So we're basically giving you exactly the same thing, or more or less the same thing. You will often be required to use this formula, and here's an example of where you may be required to use it. Firstly, we can say to you that since there's a transfer of electrons, what is the charge that was transferred? And this here is the symbol that we use for charge transferred. We say the charge transferred is equal to the final charge minus the initial charge on an object. We can either focus on Q1 or Q2. So if we focus on Q1, then we're going to take the final charge on Q1, which we calculate using this formula, minus the initial charge on Q1, which is given right at the beginning. Alternatively, we can focus on Q2, and we can say the charge transferred is equal to Q final of 2 minus Q initial of sphere 2. This will give you exactly the same answer in magnitude. The one will just be positive and the other will be negative. Again, this is how you calculate the charge that was transferred when the two spheres come into contact. Now, sometimes we will say to you, how many electrons were transferred? In that case, you will use the principle of quantization of charge, and you will say Q divided by the elementary charge. But in the place of Q, you will plug in the number that you obtained when you calculated the charge that was transferred. So in the place of Q, you will plug in charge transferred, and you will divide that by QE in order to calculate the number of electrons that were transferred when the two spheres touched. So you need to please know how to use this formula, which is normally provided to you on your formula sheet. This one over here, you also need to know how to use, but it is normally not given to you, so please learn it off by heart. Charge transferred, you also need to learn off by heart because it is normally not given to you. You also please need to remember your principle of conservation of charge as well as your principle of quantization of charge. Lastly, I'd like to remind you that in grade 10 we said If we have a positive and positive charged object, so both of the charges are the same, the two objects are going to repel each other. If we have two negatively charged objects, the charges are the same, so they're also going to repel each other. But if one object is positively charged and the other is negatively charged, then the two objects are going to be attracted to each other. This brings us to the end of this video.